So the assets that we're using, I got from this site. So Kenny is really popular. He gives all of his assets for free. They're pretty good for prototyping. If you want, I have included them in the Discord channel. Unity resources. Yeah, so I gave you a zip file with the stuff that we'll be using. It's just the 3D models, some space sounds, and then a background and a laser sprite. Yeah, so we're using this 3D bit right here. All right, and when you download Unity, it comes with Visual Studio. You can use any text editor you want. Everybody's got their choice. I like Visual Studio because it has IntelliSense, so it kind of like in the same way that Microsoft Word checks your spelling as you go along. Visual Studio checks your code as you go along, so it kind of pre-compiles it for you. I'm still waiting for my project to come up. Just a moment. Yeah, space game. All right, here we go. Come on. There we go. All right. So your layout might look a little bit different, and that's cool. Any of these windows, you can grab them by their tab, and you can move them around. So they can be freestanding. You can resize them. But I like this guy over here. Oops. Can I get him to be here? That's all right. I'll fix that. Rich's layout. Excellent. Yeah. So I like it this way. So I've got the scene. The scene is where like all your objects go. So like if you were a movie director or a director for a play, the scene is where all the action is. So you set everything up, and then when you hit the play button, it all moves and does crazy stuff. So you can see everything in your scene on the right side. Right now, it's really boring. We just have a camera and a light. So let's add something to the scene. So the project tab down here. So the project is the same thing as like your file explorer. So I'm going to left click on scenes. I'm going to right click. I'm going to hit show and explore. That's this guy here. So your project folder, as you can see, it has assets and then scenes, and in Windows Explorer or your Mac, your Finder, assets and then scenes. So it's the same interface. Windows has a little extra bit. You'll see a meta file. For every file in Unity has an accompanying meta file. You can just ignore it for now, but don't delete them. It needs to be there. So let's import that stuff we downloaded. Downloads? Nope. So resources, we'll download this bad boy. So Kennedy space assets, 7-zip, unzip, here. All right. So I'm just going to grab all this stuff, and I need to unzip these too. Yeah. No, I need hub. Yep, I'm just going to drag them in. So Unity is pretty easy. You can just, when I drag them in, it copied everything. So it's still in my downloads folder, and now it's in. If I go into this project, show and explore, there, it's all in here as well. All right, and I'm going to unzip this as well. Let Unity chug. I haven't lost anyone yet. I'm just importing the assets, getting it into Unity so that I can use them. All right, so let's get something in our scene. So I like to keep things organized. So over here in the hierarchy is what describes or lists everything that's in your scene, everything that you can use. So right now it's just the camera. And if you click on the camera, you can see a preview. And then the light. So I'm going to right click to bring up the create menu. You can also click this create button right here at the very top. And then I'm going to create an empty game object. So a game object is like your standard, like your base class for Unity. Everything attaches to a game object or is represented by a game object. And right now, an empty game object is just a transform. So it's just a position in space. So this game object is at these XYZ coordinates, has a rotation, and it has a scale. So we can make it a little bit more interesting. So I can hit create, and I can create a cube. And now this is just a marker for a cube. But so it's at this location. And if I move the game object, I move the cube with it. So it's we call this a parent-child relationship. So the cube is a child of the game object, which is a parent. But I'm going to, can I rename it? Yep, I'm going to rename this to the player. And then the cube, I'm going to delete that, and I'm going to replace it from the assets. So Unity can use a lot of different asset types. We can use FBX, and we can use OBJ. So let's see, where's my spaceships? Assets, models, spacecraft. There we go. So down here, what I did, there's this little meter. If you go all the way to the left, it's a list. If you go to the right, it makes the images bigger so you can see what they look like. So I just want a spaceship. All right, this one looks good. So I'm going to drag the one that's an FBX. Either one doesn't matter, but I'm going to stay consistent. And I'm just going to put it on the player. So Unity sometimes does something weird where its position is all wonky. So you can right-click on the component, and you can hit reset. And now it's right at the very center. It's pretty big. So we've got the player, and then we've got the object, the model of it. So I'm going to rename this to model. All right, so if we move the player, the model moves along with it. And then let's get a background going so it's a little more interesting. So I'm going to go back to my assets, and I had the space background. So Unity is flexible. It can interpret many different file types. This one is a JPEG, but it doesn't know what to do with it just yet. So I want to tell it, because a JPEG could be like a texture, or it could be a normal map, or it could be a sprite. Sprite is what we want it to be, because that's for anything that exists in the scene is typically a sprite. So I click on the space background up here for texture type. I'm changing it to sprite. And then I'm going to scroll down to hit apply. So now I get an arrow here with annotations of it, and I can just drag this into the scene now. I'll drag it into the hierarchy. Yeah, so there's our spaceship, there's our background. I'm going to rotate it by 90 degrees so that it's facing up. And then I'm going to make it big. I'm going to change its scale, let's say like 100 to 100. How does that look? All right. Pretty good. Last thing is I'm going to lower it on the y-axis so that it's below everything. Yeah. So -10 seems good. All right. Now, by all means, this is not a college class. If you have any questions, if I've lost you, I don't have to get to the end, so we can continue with the semester. If I've lost anyone, please raise your hand, let me know, because I'll just keep talking and I'll let you be. But if you need me to repeat a step, please. This is for y'all. Yeah, what's up? Yeah, totally. So space background, I dragged it into the scene, and I've got the transform. I rotated it on the x-axis. So it started at 0, and I just did 90. So if you rotate it on the y, you get everything else that way. But all right. So we also have this game tab, and right now our game tab looks really funky because the camera is inside the player model. So we can fix that by clicking on the camera, and you can change its. So you can put numbers in just straight by typing them in. But if you hover over the letter, your cursor changes to this arrow. You can kind of move it left or move it right. So I'm moving the camera right now. But you've also got these tools in the scene. So I can move it, the green arrow, I can move it up and stuff like that. There's a lot of different ways to move it. But I want to do one trick, and that's I'm going to click up here to get so I know 100%, this is kind of a shortcut to like move the scene camera to a certain position. So I know right here I'm at 90 degrees. So I'm going to click on the main camera, and I'm going to hit Control, Shift, and F. And that, so what I did up here is align with view, Control, Shift, F. So so because I clicked on the camera, I said put the camera exactly where this game view camera is. So that was kind of a shortcut to say, I don't want to, I don't want to manipulate these numbers by hand. I just want to move it this way. I'm actually going to shrink this down to like 50. That's fine. Yeah, that's all right. So Control Shift F, and the game view now kind of matches the scene view. And I want to rotate the player controller or the player model so that it's pointing up. So I'm just going to go to to the player. I'm going to go to the model because I want the model to be facing north. So I'm going to, on its y-axis, I'm going to hit 90. Oh, 180. 180 there. So now, the way I picture it is when you look at the player, it has this blue arrow. The blue arrow is telling you that that's its forward vector. So I'm matching the model's rotation to match forward. So if I tell the player to go forward, it'll go along the blue. So now that makes a little bit more sense. All right, so we have a model, we have a background, but they don't really do anything. If you want to test the game, you can always hit this play button up here, but nothing's going to happen. So let's add some behavior to our scene. So on the player, I'm going to hit Add Component, and I'm going to type in Player Controller, and I'm going to hit New Script. Create and add. Yep, Player Controller sounds good. All right. Unity's compiling, Unity's thinking. Oh, there we go. All right, player controller. So if I double click this bad boy, it'll bring up Visual Studio or whatever text editor you have set. All right. So this looks like a lot. You've got a bunch of using statements. You've got a public class, controller, model behavior. Half that stuff probably doesn't make any sense to you, and that is OK. So part of getting started is knowing what you can ignore, and you can ignore everything system. Just get rid of that. And let's just focus on these two guys right here. All mono behavior means is that it exists in the scene. So mono behavior is kind of like the base class that the base entity that everything inherits from. So let's just click on this model, and you don't have to understand what a mesh render is, but mesh render is a component or is a mono behavior, and transform is mono behavior. So that's all like the base class of it. All right. So and start and update. So start only gets called once, and then update is called every frame. So every time the game redraws the visuals, it'll call update on every object. So this is part of the game loop. Most games, they start, and then they just do something forever until the player loses or the player wins. So somewhere under the hood, Unity's doing a while loop to just do this forever. And then every time we're going to update. So to be really simple, let's just start by printing something to the console, because this is partly a programming class. So debug.log, and I'm going to put something in quotes. I'm going to say hello world. So this is the command to type something to the console. I think print works as well, but I don't know how to use that. So I just debug.log. So I'm logging hello world on start. So I'm going to go back here. I'm going to wait for Unity to compile, and I'm going to hit play. And again, nothing super incredible happens, but you see hello world showed up down here. Pretty cool, right? So we know that the game started, and we know if I go over to the console, there's hello world. So that ran when the game started. In C#, 2 slashes is a comment. So if I just prefix // now this is gone. I don't have to delete it, but it's not in the code anymore. But we want to, let's move the spaceship left and right. So to do that, we're going to use the input, or rather, we're going to use an if statement. Input get key down. Yeah. So update every single frame. We want to detect if the players press the button to move left, and we want to detect if the players press the button to move right. Pretty basic stuff. We use the input class, and then we're going to use get key. And there's 3 different variations. And Visual Studio is pretty cool. It knows Unity's documentation, so it's able to kind of guide us and hint us and say, hey, there's 3 different options we can do. So get key is for when a key is held down. Get down means this is the one frame that the player pressed the button, and then get up is the frame that the player released the button. So we're just going to do get key because you can hold them left and you can hold them right. So we're going to see key code. So every key on the board is assigned a number. So if you've used C++, if you've ever heard of an enumerated data type, that's what we're accessing right now. Is instead of saying get key A or B, we're going to use key code, and then let's do A and D. Yeah, so get key left. If you get the A, we're going to move left. Key code. And D for right. And of course, we can always change these. You can use whatever you want for movement. You can even do, I think, put.get key code. And it gives you every list, everyone you could look for. I think you can even use the arrows keys. Yeah, left alt, left arrow, left apple. No one? All right. So move right. So what we want to do is we want to manipulate the transform of the object. So this is how Unity describes where an object is. So in the scene, I can move its x position to get it moved to the left, to the right. I'm just manipulating these numbers in here, and I can set them, or I can move them like that. So I need a reference to this transform component. So this is an easy one. Since every game object has a transform component, Unity gives it to you built in. So I can say transform dot position dot x. So let's bring these up side by side. Yeah. Yeah, that's not a full statement, but so here's what I'm doing. I'm saying the transform, and that's already attached. It's already assumed to be attached to my game object, so I'm accessing this transform. And then dot position, I'm accessing the position vector, x, y, and z. And then I'm accessing its x component directly. So transform, position, x. So we want to, I'm going to use a plus equals. So I'm going to take what its value currently is, and I'm going to add or subtract a value to it. And if I press A, we want to move to the left. So I'm going to say -5. That seems like a good number to start with. Oh, nope. Can't do that. I need to do, let's do translate. Translate. Yeah. Oh, translate. All right. So translate's doing the exact same thing where it's accessing the x, y, and z formula, or x, y, z positions. But you have to do them all 3 at once. So I'm going to do -5, comma 0, and then comma 0. Comma 0. Yeah. So translating, if we all remember geometry from back in middle school, it's just moving objects along the coordinate plane. So here I've got the x, the y, and the 0, and the z. So that's x, y, and z. I only want to move to the left, and then to the right, or the 0, 0 here. So I'm going to copy this. I'm going to put it down here. And then instead of -5, we're going to do +5. Have I lost anyone yet? All right. So let's go back to Unity, let it compile. Let's see if this works. There we go. Hey, look at me go. Left, right. Exactly as intended. So let's do the same thing with up and down. I'm going to use keycode.w. I'm going to use S for down. All right, but I'm going to have no movement in the x coordinates to move up or down. Yeah, what's up, John? Yes, this is the player controller. All right, so to move up and down, I'm going to add to its z coordinate. Yeah, so because we're looking down, we don't want the player to move up and down. We want it to move forward and back. So z is the forward vector, and then z is the -5. All right, so Unity's plan, I can move up, I can move down, left, right. I can move everywhere. I can even move off the screen. So, So imagine you want to change these values, right? So someone comes in and says, hey, 5, that's way too fast, man. You're going to have to slow it down. So as a programmer, you got to go back into Visual Studio. You got to find, OK, here's every single time that I created. Okay, that's a lot of stuff. That's a lot of work to do, right? To change every one of these values in every position, that's a ton of work. So we're going to create a variable. I'm going to make it public so that it can be accessed outside of the script. And it's going to be a float, and it's going to be called move speed. So now instead of having 5s everywhere, I'm just going to delete those. I'm going to keep the minus sign because that's still relevant. But instead of 5s everywhere, let's get rid of that, get rid of that, get rid of that, get rid of that. I've got move speed. And let's set this to 5. So back into Unity, back onto the player. So notice the player script that has an extra slot right here for move speed. So now we can mess with it here. So move speed starts at 5. I entered play mode. I'm testing it. 5 seems too slow. Well, let's set it to 1. That's salt to taste. That's a little bit better. Maybe like 3. Yeah, that's all right. And then I'm gonna exit play mode, and it's stuck at 5 again. So this is, if you don't know what's going on, this can be frustrating. But when you enter play mode, you're telling all your actors to start, or like you're saying action, and then everything moves. And then you say cut, everything goes back to how it was when you first set it up. So that's good behavior because you want all your actors to go away. Anything that you created, you want it to be reset to when you started. But that means that all that tinkering I did to find out the perfect value just went away. So that is why my background turns blue when I enter play mode. It's to let me know that any changes I make in play mode won't be saved. It'll all be canned. So just keep that in mind when you're tinkering. By all means, tinker when it's in play mode, but then you have to change it outside of play mode to do that. All right. So we've got our move speed. But I want to talk about update again. So I said update runs every frame. Does anybody know how fast games run on a typical computer? Yeah, sure. Some of them run 60 frames per second. My computer can't. My computer runs 30 frames a second. So if anyone's doing math in their heads, a computer that runs at 60 frames a second, their player will move faster than on my computer. So every computer will run at a different speed. So we can do one quick little code to change that. So we're going to keep it relative to the distance that the game is playing. So this way it runs this, or the player's speed will move the same speed regardless of the machine they're on. So we're going to use time.deltaTime. So we're going to do times time delta time. Delta's fancy math speak for change. So this means the delta time is the time between frames. So on a machine that's running 60 frames a second, the delta time is like what 60 to, that's easy math, right? That's 0.1 or something. That's a nanosecond. But a machine's delta time will be twice as much on a machine that's running half as fast. So this is a way to standardize the time so that it doesn't matter if you're running at 60 frames or 100 frames or 1 frame, it'll move the same speed on everybody's machine. So I'm going to copy times that delta time and slap it onto all these. So move speed, standardize it, and back in Unity, that does change our speed value. So if we go back into play mode, it's going to slow it down drastically, I believe. Yeah, very slow. So we just have to retinker with this. I think just adding a 0 to the end of it would be all right. Maybe 60. Yeah, that's pretty good. So let's do like 75. Yeah, that works. But now it doesn't matter. So even if your machine hits like if you open up a program and your machine just decides to slow down or stutter, your game will continue to run at the same standard pace. It won't like during one frame move super quickly, then the rest of the frames move really slow. So if your computer stutters, if you're using time to delta time, it'll keep it normalized. Yeah, all right, so cool. So our guy moves, and he doesn't do much. So let's have him shoot a bullet. So first we have to create that. So in the hierarchy, I'm going to right-click or click the Create menu and hit a new game object. I'm going to call it projectile. And it's a good habit to just reset the transform back to the origin, back to 0, 0, 0, so you know where it is. And then I'm going to add a sprite to it. So back in the assets, you should have this laser red 1 that was in the Kenny asset, in the zip that I got. I didn't get that from Kenny. I got this from something else. But it should be in the zip file that I had up on Discord. Does anybody not have this red laser? Excellent. So same deal. Red laser is a PNG. Unity doesn't know what to do with it yet. So if I left-click it, I go into texture type over here in the inspector. And I'm going to do sprite 2D and UI. And then apply. So now it's got the arrow. Now it has a sprite. So I think I can just drag this guy onto the projectile. Yeah. So Unity is pretty smart. I dragged a sprite into the scene, and it already gave me a sprite render. Sprite render is just a fancy word for shows you a picture. But here is the reference to the laser that's being shown. It's this spot right here. So where are you? Probably, yep. So your orientation is weird also. So let's put 90 in the x-axis. Yeah. Yeah. Oh, reset the transform. I want it centered on itself. So let's move this somewhere else just so it's easier to see. All right, that's pretty teeny tiny. Let's make it size of like 10 or something. Yeah, there we go. It's a little bit easier to see. All right, so again, I changed the sprite orientation, not the parent orientation. I like this nesting to keep it separate, to keep like the model or the sprite separate from the game object, because that way the component, so this way the sprite is pointing, it visually looks like it's pointing towards the blue vector, the forward vector. So if I tell this thing to move forward, it'll move along the blue arrow, and I can change the orientation from there. So it's kind of confusing at first why everything is done in pairs, but it'll make a little bit more sense as we get to nesting more and more components and more parts. So I've got a projectile, I've got a sprite, and now I'm going to make what's called a prefab. So in the project, I'm going to right-click and create a folder. There we go, folder, and this is going to be called prefabs. So prefabs is a fancy word for blueprints, or it's a way to, like, I don't want to have to rebuild that projectile every time. Like I want a blueprint that describes how the projectile is set up. So in the prefabs folder, I'm just going to click on the projectile, drag it into the prefabs folder. It's going to turn it blue, and then now I have it inside the project. So now it exists like in my file system. It doesn't exist. It exists in the scene, but now it's in the file system. So now I can send this to my friend. If I open up the Explorer, I can send him the prefab, and it'll send that to him. So I can delete this out of the scene when I'm ready to. Yeah, but I want to add a script to it, right? So clicking on the projectile, I'm going to add component, and I'm going to add a projectile controller. Create and add. So what I want this projectile to do is when it gets created, I just want it to go forward forever, because that's what projectiles do in space. So double click this guy, get rid of everything I don't need. And I don't need the start. All I need is the update. So what I want to do, is I want this projectile to move, it looks like along its z-axis. I want it to go forward. So I just want to add numbers to its z-axis forever. Or its z value, yeah. So in the controller, we already have a handle to the transform. Unity gives it to us for free. And then I want to translate it. Yeah, what's up?
I mean, sure, we're applying the same movement as the player. Can we do get key like first? First you gotta define the get key.
Well, so you're on the right track. So we do need to get a get key. We need to know when to put the projectile into the scene to get it to move forward, like to shoot the gun. It needs to spawn one and then move it forward, and we'll get there. But for this guy, as soon as it's in the scene, it just needs to go forward. That's all it really has to do. So transform 0, don't move left or right, don't move up and down, only move forward. Now let's do the same thing we did before. I don't want to have to come back into the script to change it. So I'm going to say move speed times time dot delta time. Right. So again, public float move speed. Bullets move pretty fast. Let's make it 150. So let's test if it works. If it works on this one, it'll work for all of them. So hit play, and that thing should just go away. Yep, there it goes. And it'll just keep going forever. Yep, can I follow it? Nah, it's moving too fast. All right. So something to note is I made the change to the projectile in the scene. So over here, this little, it's got a plus next to the script, and it's blue. This is just telling me that this projectile in the scene is different from this prefab. So I can fix that by clicking on this button over here. This is overrides, and I'm gonna hit apply all. And this is like saving the prefab. So now that projectile controller is on the projectile that's in my scene, or that's in the project. So these two are identical. So I can just delete this now. I don't need it. But in my prefabs folder projectile, I've got everything I need. So now I need to do two things. I need to link the prefab to the player controller so the player controller knows what to create when it fires, and then the firing script so that every time you press a button, it'll instantiate the thing and push it forward. So on the player, let's pull that back. So I'm back in the player controller. I need another public reference, and I'm going to reference a game object. So game object is like it's like your root object that everything sits on. So most or all model behaviors sit on a game object. So I want the game object, and this is going to be called the projectile prefab. All right. Back in Unity, I'll let it compile, and our player controller now has this empty slot. So it says none. So I'm going to take the projectile that is in the one that's in the project, and it's got to be, or it should be the one that's in the project, and I'm going to put it into that slot. It's drag and drop. It's pretty cool. So now anytime in this script, if I reference the projectile prefab, I'm referencing the thing that's in this slot. That was a lot to take in. Is everyone still on board? Everyone still following? Any questions so far? All right. Yeah, what's up? Yep. Practice. Practice in Google. So how do I know what everything is? Yeah. So input, tutorials, practice. You have a question, you just type it into Google. So the secret to programming and game development is we Google everything. So Unity, how to move an object with keyboard. And Unity's been around for so long. It has a great community. You heading out, man? It was good to meet you, Hassan. Yeah. So there's tutorials for days. There's all kinds of stuff. Unity's been around forever. I've been doing Unity for like 5 years, and I have not asked a question that was unanswered, or I just asked the question wrong. But everything's out there. There's also the Unity documentation. So if you type in Unity docs, the Unity user manual, yeah. So everything you need to know. I don't expect anyone to like sit here and read through this. That's a it's a huge manual, but you can just type into Google Unity input. The first thing that comes up in Google, and I think this will have, yeah, here's all of our functions, like everything that we can mess with. So here, static methods. Here's our get button, or get key is what we're using right now. Get key down. So you can look at this stuff to get more information of what's exactly happening. Yeah. All right. So I'm picky, and this is a whole lot of code to look at. So I'm going to create a function. So I'm going to call this function, it's a void, which means it's not going to return anything. It's just going to do stuff. And it's going to be called do movement. And I'm going to take all this noise, copy it, paste it, do movement. All right, so I didn't change the code at all. That was kind of quick, but I created a new function called void do movement, and then I put all the input stuff in there. So that's just for me, so that when I look at update, I just see one function call. Oh, it's movement. Okay, that's easy to do. And then all that stuff was in here. So that's just a little bit easier for me to read. Was that too fast? All right. So all the void means is that the function doesn't return anything. It just does this when you call it. So underneath do movement separately, I want to do projectile or do shooting, I guess. So private void do shooting, same thing. Do you have a question?
So I'm very far behind.
Yeah, no worries.
I'm super far behind. Like I don't have any of the code down yet.
Mm-hmm. I can throw it up on Discord for you. Sorry, I type like 100 words a minute. I apologize. Projectile controller, player controller, Discord. Player controller. I'll slow down a little bit, let you guys catch up. Sorry, I get carried away. Yeah. Oh, 1 second, dude. What's up? Yeah. Right. So there's two access modifiers, or two main ones. There's public and there's private. So public means it can be accessed outside of the script, and private means only this script can do this. So private is the default. So there's nothing in front of void or in front of start, update, or do movement. But private is the default. So these are all private. So this means that if somehow some other script got access to my player controller, it couldn't tell my player controller to do shooting. The only one who should do shooting is itself. So it's we talk about, the term is data encapsulation. So scripts should only give each other as much information as the other needs and no more. So so public and float, like that's the only thing that should be exposed. Like nothing else, like everything else should just be handled by, or just handled internally. Does that kind of make sense? All right. And what's up? No, I want to give you time to catch up or ask questions and stuff. Where are you guys at now? Huh? All right. No worries. So what was that last bit? Comments. Oh, yeah, I can totally do comments. That's a good point. Always comment your code. But also, when I'm done with this, I'll put it all on GitHub and have a link so that at the end of this lecture, you can download it, and it'll be the exact same state that I left it. And then every week, we'll just add to that same GitHub. So so that next time you come, you can at least be at the same stage that I am, and you don't have to catch up. Cool. But yeah, I can totally do more comments. So if a key is pressed, move X or decrease X value. Yeah, I'll make sure to go through. I'll add a bunch more comments, and I'll make this a little bit more readable. But so what's going on right now is we have so we've got our movement and we've got our shooting. I just moved it out of the update function just so it's a little easier to read, but it's doing the exact same thing. When it does movement, it just goes down here to movement, and then it does the same thing. But now we're going to do shooting. So it's another thing where we're going to check for input, and we're going to use the input dot get key. What's up? How about space? Because I'm using the WSAD, so space is really easy to hit. Key code dot space. Yeah. So notice in this case, for when we were doing movement, I just did get key. So that implies that while the key is held down, this will be true. So this whole statement, input.getKey, this resolves to a Boolean. It's true or false. So while this frame is happening, is this key held down? In this case, we're using getKey down. So was this the one frame that the button was pressed down? So getKey only happens once per press, whereas getKey is constant while the button is placed. So in our game, I'm setting it so that you have to press the button repeatedly to shoot. It's not a hold down to shoot. We can always change that, but I wanted to do something different. Yeah. So if we press the key down, I want to, or the frame. Now we'll do pressed. All right. So we're doing the shooting, and we need to create the projectile. Hey, take it easy, man. Thanks for coming by. Tony. Yeah, what's up?
The prefab is not actually in the scene.
Mm-hmm.
Prefab, and once the prefab is created, it immediately executes.
Mm-hmm. Yep, that's exactly what we're doing right now. So when the button is pressed down, we want to instantiate is the fancy word for putting an object into the scene, or like creating or copying. So instantiate is like your go-to. How do I get something? How do I create a copy of something? Or how do I like take something that's in the project and put it into the scene using code? We use instantiate. So what are we going to instantiate? We're going to do our projectile prefab, but we need to tell it where. So this is enough for Unity to know to put this into the scene, but we need to know where to put it. So I'm going to do a copy or a comma, and we're going to do transform.position. So where do I want this object to be spawned? On my position, at the center of where the player controller is. Because right now we're in the player controller script. So at the player controller's origin, if you will. But we need one more thing. This is gonna be ugly. I apologize. This is describing a rotation. So we're saying what are we spawning, where are we spawning it, and how, like what is the rotation? That's really ugly, but this just means 0, 0, 0. This means no rotation at all. Quaternion is the big fancy word for rotations, but this just means no rotation, exactly how it is in the prefab. Just preserve or keep that. So we're saying no rotation. So create an object or copy this object that I gave you, put it here, and rotate it in this way. So I think that's enough. If we do get instantiate it. Yeah, I think that's enough. Let's try it. So we're compiling, player. So we have the projectile. Yeah, let's try it. Here's my game view. I can move, and I hit the space button, and boom, teeny tiny, and there it goes. All right, we can shoot. Zoom, zoom, zoom. There, and they just go on forever. Look at them go. Forever. So C#, so maybe you guys have heard the term memory leak before. C# is really cool. There's no memory leaks in C#. However, in Unity, that concept does kind of exist. So I'm instantiating things. And these bullets, I haven't told them anyway. They'll just go on forever, and they'll be in the scene forever. And after an hour of playing my game, eventually my computer's going to run out of memory. That's a long way off. These are really small things, but that's a problem. Eventually that will cause a problem. It'll slow the game down, and that'll be an issue. So let's fix that. So it's super easy, and you don't always have to do this. This is just if you want to delete something after a certain time. So I'm going back into the projectile controller because this is a problem with the projectile, so that's where I want to put the code for it. I'm going to bring that start function back. I don't need that. Just get rid of that. All right. And so I know this, but if you want to ask the question, how do I destroy something in Unity? Destroy object. It'll tell you, object.destroy. So if you don't know what to do, you can just, that's the big secret of game development is we Google everything. So don't be afraid to just type your question into Google. But the answer that I was looking for is destroy. So yeah, what's up? Yeah, you're actually right. You're absolutely right. So start is called when the object is created or when the game starts, because we're instantiating these at runtime, so start will be called when that object is created. So we can't just destroy it right away, otherwise it won't move anywhere. So we have a few options of how to solve that problem. You brought up, Keon, you brought up we can destroy it after time. We can also destroy it after distance or after displacement, or there's a lot of different ways to solve this problem. But I like, you said time, so I like that's a really easy solution to implement. So when the game starts, we want to call this function called destroy, and we're going to destroy this .game object. So this is a pointer to, because you know when we start the game and we spawn 1,000 projectiles, there's going to be 1,000 projectile controllers in the scene. So, but we want this one, like the current one, or like the individual one. So we want to destroy this game object, but this will destroy it as soon as it's created, and that's no good. We want to destroy it after time. Yeah, also on collide. So back up here, let's do public float lifespan is a good word. Lifespan, and we'll call this 5 seconds. So move speed. What's up? Yeah, we can come back to that. When we do like damaging the player, I can circle back to that. I'm just adding a couple comments right now. Destroys many seconds. All right, so these are just really, really fancy comments. So you can put these in anywhere. You just do in Visual Studio, you just do the / 3 times. And so anytime I hover over lifespan, it'll tell me what it does right here. So that's like a super comment, or an XML comment if you want to get super fancy. So those have no impact on the game. They're just comments to document the code. So we have this lifespan. So let me look up the documentation for destroy real quick, just so you can see it. Oh yeah, it's right here. All right, so it looks like this is the signature, so this is what we can tell it. So we can give it an object, and then it has float equals 0. The equals, this means that if we don't give it any time, it'll destroy it immediately. But we can give it a time, and it'll wait that much time before destroying it. So that's a built-in feature that's pretty easy to, that's really easy to implement. So back in our projectile controller, destroy this game object, comma, lifespan. So, this we do this on start because it's really like mark this for destroy. So after this many seconds, it'll destroy this object. So if we this .game object. So the game object that this component is attached to. Yeah, what's up, John? What's up? So start happens when you, so if the object is in the scene, start will happen when you press start. Otherwise, it's called the frame after you instantiate. So you instantiate, that whole frame finishes, next frame begins, and then it calls start on every object that was instantiated. So, but in our case, we're using destroy with the lifespan, so it won't destroy it right away. It'll destroy it. It'll mark it for destruction right away, but then it'll wait this many seconds. So I just want to prove to make sure that works to myself. So I'm going to fly around, hit that. We should be seeing a whole bunch. And then we should see them. Yep, there they go. They're getting cleaned up by themselves. There they go, and they're all gone. We have solved our memory leak. We can play our game for infinity, for as long as we want now, and nothing bad will ever happen. So 5 seconds pass, and there they go, destroying themselves. Awesome. So that, again, in programming in Unity, or any programming, there's more than one way to solve the problem. That was an easy way to do it with time, but we do want to know when it hits something. When it hits something, it needs to be destroyed too. Yeah, collision.
Replacing the time code with object, the name of the object, so that might do.
Yeah. All right, so let's make an enemy really quick. Well, does anyone else have any other questions before I move on and do enemy stuff? Yeah, what's up, Ben?
When you like shoot a lot, or I mean like when you shoot, I noticed that the projectile can like stop rendering after.
It does, yeah. Yeah, I think that's a camera thing. Let me see if I can fix that. Clipping planes far. Let me set this to 5,000. Let me see if that fixes it. No. No rotations. You know, I don't exactly know why it's doing that. I'll figure that out at a later time. We know that they do keep going. It's just a rendering. Versus why does it stop rendering it? I'll circle around to that. I don't want to waste a time period troubleshooting that, but I'll figure it out and I'll let you know exactly why. All right. I also want to make those bigger. So I can click on my projectile. Let's do 20 by 20, twice as big. Yeah. Cool. All right, so let's give our player something to blow up. So I want to make another enemy. So in the hierarchy, I'm going to right-click and create an object or an empty game object, and I'm going to name it enemy ship. I'm going to reset its transform so that it's at the origin, just so I know I just know where it is. Yeah. All right. Now I need a model. So let's go back into our models. I'm back into the Kenny assets, and let's just find another ship. Give me a ship. Spacecraft 6 sounds good. FBX, all right, drag it in there, sweet. So if you notice, when I click on my enemy ship's origin is right here, but if I click on the actual model of it, it's over here. I don't like that. I like the two to be together. So I'm going to reset this guy's transform so that he's at the center. They're at the same place. There's no like weird offset or anything. I'm going to do the same rotation trick where I'm going to rotate this guy 180 degrees on the y-axis so that the ship is pointing towards its parent's blue arrow. So if I say move forward, it'll move this way. So everything's relative that way. I'm going to rename this to model. All right. And now I want to be able to instantiate these on the fly at runtime. So I'm going to do the same prefab technique. So my projects, I've got assets, prefabs, and I'm just going to grab the enemy ship and drop it in there. Now I've got an enemy and a projectile. All right. Now we need to know, we're going to do collision. So our bullet needs to know that it's hit something. So Unity has these tools set up for us that it's called colliders. So I'm going to add a component on the right. So I'm on the enemy ship. I clicked add component, and I'm typing the word collider. And there's a whole bunch of different colliders. Wheels, 2D, 3D. This is a pretty simple game, so I'm just going to do a box collider. Now I want it to be the same like shape as the ship. So I'm going to hit this button right here. This says Edit Collider. And then it's kind of hard to see right now because it's so small, but let me increase it. So let's make it big this way. Let's make it bigger this way. So I'm going to offset it a little bit, get it towards its center. And then let's get its Y. How tall is it? Y doesn't matter as much, but let's make it taller. Oh. Okay. Yeah. So you can. This is also. You may have heard the term hitbox. This is the hitbox. So if any part of this collider gets hit, we'll be able to detect collision from it. I also want to click this box right here that says is trigger. So I'm not using the physics engine, I'm using translation. And so I want this to be a trigger. So a regular collider will actually stop like physics objects, but a trigger collider is like if a player enters a room, you want to know if they entered the room, that's a trigger. Like is the player on, like did the player stand on this switch? Like that's a trigger. Or like proximity, is my player close enough to my enemy to be detected? That's a trigger because that sphere doesn't stop the player, just alerts it so it's like it's a volume. So is trigger is important. So we've got an enemy ship. It's got a box collider. All right. So these are changes that I made to the object in the scene, but I want to make sure that those are on my prefab so that when I instantiate it, it has those same properties. So I'm going to hit the override button and hit apply all. So the blue goes away, and over here, enemy ship, it has a box collider. So it's like saving it essentially. So I can delete this. And if I bring it in, enemy ship, bring it in, it's exactly the same. All right. So let's just put 3 of those guys in. Enemy ship. Yeah, it looks good right there. How about reset you? All right. How about full 180? Put you there. So I want to make copies of this guy. Control C doesn't work in Unity. It does something different. We want to use duplicate, not copy. So I'm going to hit Control D to create a copy of it. So it's exactly in the same place. Control D. And I've got 3 enemies. Let's do one more. All right. And I'm ridiculous. I don't like how there's 4 enemies at the root of my hierarchy. So I'm going to like nest them a little bit. So I'm going to create a game object. I'm going to create an empty one. Oops. I'm just going to call this enemies. I'm going to treat it like a folder. So all my enemy 1, 2, 3, 4 underneath. So that just helps me clean it up a little bit. So I know all my enemies. It's a little wasteful, but I don't care. It's a folder. It helps me stay organized. I like it. So here's all my enemies. They're inside an empty game object that does nothing. It just holds my enemies. And I can also move them all at once if I want to. All right. So we have an enemy with a collider. Our projectile needs a collider also. So let's bring the projectile back into the scene so we can work on it. There it is. So I'm going to add component, give it another box collider. I'm going to edit it, shrink it down a little bit. We want it to be kind of big so that it's easy to hit, but not too big. Shrink that in. Yeah, that looks good. All right, and then one more bit. So in order for Unity to detect physics, it needs 2 things. Both of the objects need a collider, and then one of them needs a rigid body. And that's a super fancy term for the physics engine is aware of this object. So I'm going to put the rigid body on the projectile. So add component, rigid body. And I'm going to turn off gravity, and I'm going to turn on is kinematic. And that's all I have to do. Hey, take it easy. Thanks for coming. All right, so that's a big step. But I turned off gravity because our bullet I don't want it to fall down the y-axis. I just want it to go straight, so gravity's off. And then is kinematic is on. Kinematic means we're using translation to affect our objects. We're not using physics. Like we're not adding force or anything. So is kinematic means be aware of this physics or of this object, but don't apply physics to it, if that makes sense. Like we'll handle that. So again, I made these changes in the scene, so I need to save it to the prefab. So I'm going to hit overrides, apply all. And now I can delete it. All right, so I believe this is nearly enough. All right. Hey, thanks for coming, guys. I'll make sure this is all on GitHub, and we'll have a recording, so if you want, you can finish up. But it was good to see you guys. It was good to meet you, Zach. All right, so there's one more piece. We just need, we need the script to know that the 2 things have come into contact. So Unity knows, but the script needs to know. So on the projectile controller, we're going to add a new function, and it's going to be called void on trigger enter. So again, I start typing on trigger, and we get a whole bunch. So there's many different things, but I just want on trigger enter. So private just means no one else is going to call on trigger enter. We will call on trigger enter ourselves. And then the collider, this is the thing that we collided with. So we know that one half of the collision is us, is the script, and the other half is the collider. We can refer it to it other if we want to. So if this laser hits something, we want to destroy ourselves, this .game object. So destroy the projectile immediately, and then also destroy other .game objects. All right, so if this projectile hits something, Unity, because we gave it a trigger, we checked trigger on and trigger enter, we'll get this callback. Unity will call this function itself. And we'll destroy ourselves, and then we'll destroy the thing that we hit. So this is pretty powerful laser. It'll destroy anything. It's Starkiller base. So let's see if this works. All right, movement still works. Lasers, there we go. Lasers, go, dink. Oh, that's weird. And shoot. Ah, sometimes they don't show up. That's weird. Are they underneath the background? Yeah. There we go. For some reason, the background's like overlapping. Okay, Ben, I figured out your problem. So the lasers, the lasers are a sprite, and the background is a sprite, and they're on the same layer. So it's called Z fighting. They're both like it's two pieces of papers that are like it's not one piece of paper on top of the other. They're like both in the same place. So the space background, one extra thing is it has this order and layer. I'm just going to drop that down to -1. So the projectiles are 0. This is -1. So I believe that should make our projectiles should always be on top now. Yeah, there we go. Cool. So sorry about that. I forgot to do that. So the background, we don't want our background to mess with anything. So I put it down to a different layer. And everything else will be on top of it. So now we can shoot. And we can get pretty close, but there, we hit it. We hit it. It destroys. It destroys. It destroys. Space Invaders. Any questions so far? I know I moved kind of fast. Is anybody behind? Anybody wants me to clarify something? John, what's up, John? You raised your hand. Yeah, so I clicked on space background, and it's a sprite renderer. And then you may have to press this additional settings button to get it to show up. And then I just set -1. Yeah, yeah. So they were both. Yeah, they were Z fighting is the super technical term. Yeah, no problem. Ben, you all right? All right. Hanging in there? All right. I feel like that's a good place to stop for this 101 tutorial. Next week, we can do the enemy shooting back, and we can do like health, and we can do UI and stuff like that too.